Is insights of tropical cyclones responses to global warming from GNSS radio occultation data over the past 16 years.
Okay, good morning, everyone. And I'm Shi Yu, and I'm doing my postdoc in the Department of Civil Environmental and Engineering for Hong Kong University of Science and Technology. And my topic is a try to insights of the tropical cyclones response to global warming from GNSS data over the past 16 years. And I also acknowledge my current supervisor from Professor Su Hui and my PhD supervisor, Professor George Liu from Department of Land Surveying and Geoinformatics from Hong Kong Polytechnic Universities. And I will talk about my presentation in four aspects. The first, I will talk about the background of the climate change. And the second is the data and methodology. And then I will present the results and discussion on the results. And finally, I will make a conclusion. And here I provide a bigger picture of the climate change. And as we know, the global temperature increased around 1.1 degrees Celsius since the pre-industrial period, and due to the increase of the greenhouse gas emissions. And it induced huge environmental problems, such as the decrease of the sea ice and the increase of the sea levels. And how about the impact of the global change to the tropical cyclone properties? Here I provided two examples. The first figure shows the decrease in corner rainfalls, which means the rainfall decreased in the TC in core area within 200 kilometers from T center. And the reason is that this paper found that the vertical velocity decreased due to the global change. And the second example is the slowdown of the TC translation speed. And in our study, we want to use GNSS radio occultation data to investigate the TC's characteristics to the response to the global warming, because GNSS data has a high resolution temporal and spatial resolutions, and also it can provide in situ observations in the TC area. And here we pick out the 10 radio occultation missions, and 9 is nine products from the post-processing data of the level 2 atmosphere profiles. And there is one that is the Cosmic 2, is the near real-time product. And before we discuss the climate change from the GNSS radio occultation data, we estimated the radio occultation data of accuracy in terms of water vapor accuracy. And here we show the assessment result. And you can see the overall the accuracy of the 10 missions is around 3 millimeters. And the best is from the Greece. It has the 3.5 millimeters with respect to the GNSS ground GNSS water vapor observation, and 3.2 millimeter for the compared to the radio sound water vapor observations. And here we can see the largest bias is for the Cosmic 2, because it is a near real-time product. And here is our study area. We selected the five TC basins, and Western, Eastern, North Pacific, and North Atlantic in the North Hemisphere, and South India and the Southwest Pacific Oceans basins in the South Hemisphere. We exclude the North India basins because there is the limited observations, our observations in this basin. And here I provide a short-term trend in sea surface temperature anomaly retrieved from extended reconstruction sea surface temperature from the NOAA, and the water vapor precipitated table water vapor trend from retrieved from EI5. And here we can see for the in the area of the west and east North Pacific and North Atlantic, the sea surface temperature increased very significantly. But for the for the South Hemisphere, particularly in the west of the Australia, the sea surface showed not significant increase. It showed a decreased trade, and correspondingly, the water vapor content showed a significant increase in the North Hemisphere, but for the South Hemisphere, the water vapor showed different patterns. It showed exchange temperature with the decrease and increase, because the ITCZ, the intertropical convection region, is north has a north shift trend in recent years. And before here is I pick to study the tropical cyclone water vapor. We selected the RO profiles, which called ROTCPLs. We conduct 4 quality controls. The first is we select the profile with the TC intensity, with the category from category 1 to category 5, and the second is we just apply profiles with the TC in the development stage, which means that the wind speed of the TC has an increased rate. And the third one is with the profile located in the 600 kilometers from the TC center, and also the penetrate deeps reaches the 1.6 kilometers. We all included our study, and the counter map shows the ROTCPL's spatial distribution, and we can see most of the ROTCPL appear in the east North Pacific and west North Pacific, which accounts for about around more than 50%. And here let's look at the result. Here's the mixing ratio trend in different altitudes for different basins and on global scales. And the left panel shows the absolute trend, and the middle panel shows the observation along the altitude. And the right panel shows the percentage increase respect to the observation in 2008. And here I just pick a level ranged 1.6 kilometer to 3 kilometers, because the penetration capacity of the RO is very limited in the below the 1.6 kilometer, and also the humidity above the 3 kilometers that are very small. So for this level, the increase of the mixing ratio trade is around 0.03 gram of kilogram per year, which will equal to 7.8%. And here I also provide the water vapor for this altitude layer. We integrated the mix ratio along the altitude, and we can see there is a significant increased trade from the 4 different range bands. And here is the final statistical result, and we can see for the North Atlantic and South India and West South Pacific shows a great increasement of the water vapor. But for the East North Pacific and West Pacific, it shows a relatively small increase. And on average, on global scale, it shows around 12% for 1 K increase of the increase in temperature. And this is a little bit larger than the closest cooperation relation, which says there is the water capacity of the atmosphere increased by around 7% for 1 degree Celsius increase in atmosphere, because the tropical cyclone is a very dynamic system, not a stationary system. And here we also investigated the relationship between the water vapor and the total precipitation, and Here, the red trade line shows the water vapor trade, and the blue line shows the precipitation trade. And this result is consistent with the decreased rainfall trend in the core area, which I mentioned in the background. And we can also find the out of the inner core area, the water vapor and precipitation shows a consistent increased trade. And also, we also discussed a special relationship. We selected the water vapor and the total precipitation sounding point. Then we using radial basic function interpolated to the 5 time per 5 grade degree to get a map for each year. Then we apply the linear regression on each grade, and then we can get a water vapor trade map. Here is the result for the water vapor trade map, and here we can see for the most of the basins shows the significant increased trade of the water vapor, which means that the tropical cyclone are bringing a lot of water vapors from the ocean to the coastal area, and but the precipitation didn't show a consistent increase because we think we use the emerged precipitation because the high cost resolution of the temporal and spatial resolution may affect the result of this trade. And another problem is the dynamic of the oceans in the North Atlantic and East North Pacific can attribute this result. And maybe we will more time to investigate this inconsistent result for the precipitation trade. And this is let's make a conclusion of our study. And globally, the SST increased by 0.02 degrees Celsius per year. Then sequentially, the water vapor increased by 0.05 millimeter per year. And for the mixing ratio of the water vapor increased by 0.3 gram per gram per year, which equal to 7.8 percentage per year. And the third is the TC water vapor increased around 12% for 1 degree Celsius increase in the air temperature due to the high dynamic systems of the TC. And the final point is the changes of TC total precipitation is not consistent with the change of the water vapor. We are going on this study to investigate maybe the other factors that affect the precipitation, such as the wind chill and also the vertical velocities. Yeah, that's all. Thank you.
Thank you, Siwei. Do you have any questions? Yes.
Can you go back to the previous? The mixing ratio looks too high in terms of percentage. I mean, that would mean that if that's 7.8%, the mixing ratio would be about 0.5 grams per kilogram at 1.6 to 3 kilometers. I think it's quite a bit higher than that, isn't it? I mean, I would think it's more like in the single digits rather than half.
I think because the reference is compared to the 2008 values.
Okay. Yeah. But I mean, at that rate, the water vapor is going to double in 12 years or something like that.
But the 12% is not for the per year, it's for the 1 degree increase in the...
I meant the one above that, the 7.8% per year.
Yeah.
It just seems too, I think the percentage number seems too high to me.
Oh.
That's all. It may be. Anyway, great talk, but I just think that percentage number is too high. It's a very interesting talk.
Well, I would like to thank all speakers again for the morning session. And we're going on a break, and we should be back at